All right, class. In this video, we continue our discussion of section 6.4 in your note packet on the fundamental theorem of calculus. And so we're going to be working some word problems starting with example 1 on page 86. And so we are given the following as part of quality control. An efficiency study found that the rate at which packages are inspected at Amazon Marketplace by the typical worker, T hours after starting work at AM, is given by this derivative. N prime of t is equal to minus 3t squared plus 12t plus 15 for t equal to 0 to 4. So t equals 0 to 4, t equals 0 corresponds to 8 a.m., t equals 4 would correspond to 12 noon. In part A, you're asked to find an expression n of t that approximates the number of sets inspected at the end of t hours. Well, n of t is equal to the antiderivative of n prime of t to within an unknown constant c. And n prime of t, right, is equal to this function. And when we anti-differentiate it, we get n of t is equal to minus t cubed plus 6t squared plus 15t plus the unknown constant c, which we got to figure out what it is. Well, workers arrive at 8 a.m., right? They start work at 8 a.m. T equals 0 is equal to 8 a.m. So the number of sets inspected at 8 a.m. or t equals 0 is 0. So we plug in 0 in for t, and we get n of 0 is equal to c, right? Because these first three terms will equal 0. And n of 0 is equal to 0, so we just get c is equal to 0. So we replace c with 0, and we have n of t is equal to minus t cubed plus 6t squared plus 15t. So this is the answer to part A here. In part B, we're asked, how many packages does the typical worker inspect during the morning shift from 8 a.m. to noon? Well, t equals 4, right, for 12 noon. So in our function up here, we would just plug in 4 in for t, and we have n of 4 is equal to minus 4 cubed plus 6 times 4 squared plus 15 times 4. And when you do the arithmetic, you get 92 packages. So the number of packages the typical worker inspects during the morning shift from 8 a.m. to 12 noon is 92 packages. All right, so if we flip over to the next page, page 87, in example 2, you're given out-of-pocket expenses for health care is projected to increase over the next several years. The amount spent annually from 2015 is expected to grow at the rate of R of t here. So t equals 0 corresponds to the year 2015. And this is a rate, right? So this is a rate of change as a function of time. R of t is equal to 1.1 t plus 16.89. And this rate, right, this expected growth rate is for t equals 0 to 5. So t equals 0 is 2015. And t equals 5 would then correspond to the year 2020. So it's expected to grow at the rate of R of t, and R of t, the units for that rate of change is $1 billion per year. And we're given the national spending in 2015 was $410 billion. In part A, you're asked to find an expression A of t that approximates the projected total spending. So R of t and A prime of t, the derivative of A of t, are the same thing. A prime of t, right, the derivative of A of t and R of t are the same thing. So to find A of t, we anti-differentiate its derivative, R of t, with respect to t, and R of t is 1.1 t plus 16.89. And when we anti-differentiate this function, we get A of t is equal to 0.55 t squared plus 16.89 t plus the unknown constant c. Well, we're told that The national spending in 2015 is $410 billion, and T equals 0 corresponds to the year 2015. So we have A of 0, right, the spending in 2015, A of 0 is equal to 410. So plugging in 0 in for T in our function over here, we get A of 0 is equal to C, right? Because these two terms are equal to 0 when you put 0 in for T. But A of 0 is equal to 410, so we have 410 is equal to C, or C is equal to 410. And then when we replace C up here with 410, we get A of T is equal to 0.55 T squared plus 16.89 T plus 410. So this is the answer to our question in part A. Find an expression A of T that approximates the projected total spending. And then part B asks, what is the projected spending in 2021? Well, if 2015 corresponds to T equals 0, then 2021 corresponds to T equals 6. So to find this projected spending in 2021, we just put in 6 in for T up here, and we have A of 6 is equal to 0.55 times 6 squared plus 16.89 times 6 plus 410. And when you do that arithmetic, you get A of 6 is equal to $531.14 billion. Remember, A is in billions of dollars. And so projected spending in 2021 is $531.14 billion.